Great, so let's get started. My name is Stefan, and I'm a member of the support team here at SeisWare. And in today's workflow, I want to walk through how we can go ahead creating and using our cross-section tool in SeisWare. And then I want to show how a current geophysicist might be able to utilize this in their workflows. The example I'll give today is how you can use this cross-section tool to QC and tidy up your time depth velocity models. So I'll just jump right into it. When we're talking about cross-sections in SeisWare, there are three different ways of defining a cross-section. The first being just XY points on the base map, which is simply just clicking out points on the base map in SeisWare will draw a cross-section between them. We can also do it between wells. This is what I did in this pink cross-section here. I simply select different wells, and SeisWare draws a straight line between each of those wells and creates the cross-section. Or finally, I can create a cross-section along a wellbore. So this comes in handy when you have horizontal or lateral wells. An example, the cross-section in blue here on my base map, we can create a cross-section that just follows the wellbore. So if I jump into our cross-section viewer here, I'll first take a look at this cross-section along a wellbore. So looking at the cross-section tool, we have 5 different types of data we can display here. The first being well data, and that's just displayed as headers or footers, or both. In this case here, I'm simply just showing the name, the common name of the well as my header, but you could also show any kind of general well information here. UWI, the symbol, depths, datums, and the such. The second piece of data that we can show has to do with tops. We can show our formations here. So I'm showing 2 in orange and blue there. The third piece of data we can show is actually our log curve data, our tracks. In this case here, you can see I'm showing a gamma ray curve on the outside and total gas on the inside. The way we like to show our tracks and log curves in SeisWare is through something we call the well template designer. So use the designer, you create templates, and you keep using those templates through all the different aspects of SeisWare. So it makes it really easy to always look at your curves in the same method, in the same way, whether you're in the cross-section viewer like this, or if you jump to the seismic view, you want to look at that same well, you're looking at it in the same way. It's also really easy to share these log curve templates with different users or between projects. So back in the cross-section here, the fourth piece of data that we can show is grids. And the example I have here today in pink is my Crow Mountain formation grid. And this is the actual formation that this well was drilled into. So what I can do here is see how the interaction between my formation grid and my well bore as I drill along the lateral here. And where this comes in handy and brings into the fifth type of data we can show in the cross-section is zones. So zones are just defined depths along a well bore. You might have heard them called stages or thicknesses in other softwares. And where I've used this here, it can show frac stages or perfs or locations. In this case, I'm showing where I'm in and out of formation based off how my formation grid interacts with my well bore. You can see here I've highlighted in those red zones where I've gone out of formation. This is one example of a cross-section. I'm going to jump over to the main cross-section I'll use today. And this is that pink cross-section you saw on the base map there. So when we're looking at here, you can see I'm again showing my basic well information as headers. In this case, I've included the symbol. I have 4 different tops I'm displaying. They're all color-coded. And this time I'm using a different well template. In this case, I have my gamma ratio on the far left track here. That middle track has 2 resistivity curves. And on the far right track, I have a neutron porosity and a density curve. Now, when we look at cross-section tools, a big utilization of that is going to be picking and editing tops. And SeisWare has a really cool predictive tops tool picking that automatically looks to all the wells around it to predict what top you're trying to pick. So as an example here, I can go through and pick my Fall River formation, but without having to manually change anything, I can go down and also pick the Lakota and the Red P. And I can really quickly work through my well going like this, going all the way through my cross-section. So they can really just easily make it quick and easy to pick those tops without having to manually change each time you want to pick a different top. Now we've gone through how to create these cross-sections and edit them, I want to show you how you might be able to fit this in your current workflows. So I'll jump over and show you a really basic single layer time depth velocity model. And when I look at this velocity model, I have a pretty good get velocity grid, but my depth grid, which is built off those Crow Mountain formation tops you saw in my cross-section, is looking a little odd. Now I take a closer look in my cross plot here or my depth histogram. I have one point that's really standing out. When I sort my wells by my depth residual, one point is standing out with a giant residual. I want to take a closer look at it. And that's where that cross-section tool can come really in handy. So one thing I didn't mention that's really helpful with our cross-section tool is we automatically generate a temporary grid for every formation top that is present in your cross-section. So what that looks like, looking at my base map here, is I have these temporary formation grids created for all the tops in my cross-section. And if I turn on the Crow Mountain formation, I can see it looks okay, but there's definitely something strange, a hotspot looking right at that corner bend. When I zoom in a little bit, it becomes a lot more evident something's going on there. So I can jump back to my cross section and take a look at that location. And I definitely see that that pick was incorrect. If it was badly loaded or just a bad pick, it's definitely wrong. And I can go ahead myself and move it into a better location. If I go ahead and shift that down to where it's probably supposed to sit and take a look at my formation grid, you can see it updates on the fly. What else updates on the fly is my velocity model. You can see it's now updated on the fly. My depth grid looks much better. I no longer have any crazy outlying points in my cross plot or my depth histogram, and my depth residuals are a lot more normal. So in the example today, I've shown how we can go ahead and create and edit some cross sections using that tool in our geology package, and how as a current geophysics user, you might be able to use that in your current workflow to tidy up or QC some velocity models, saving you the effort of having to call the geologist and see what's going on. You take a look for yourself. I hope you found that informative and have a great day.